All right, so this is our last lesson here, evaluating inverse trig functions. So if you recall, the inverse of a trig function is used to find the measure of an angle. So the angles that we're going to be looking for today will be theta. So let's take a look at this first one here. We have sine theta is equal to 1/2. Now, remember that sine stands for the y value. And the y value that we want is 1/2. So this is also telling us we're looking at quadrant 2 for this problem. So what I'm going to do first here is I'm going to graph my angle. And since it's telling me I'm between pi over 2 and pi, that's what's telling me that I'm in that second quadrant. So remember, when you guys make an angle, make sure that it's always touching the x-axis. So this is my reference angle right here. My y value is 1/2, or you could write it as an ordered pair, because that's what this ordered pair is right here. The y value is 1/2. The one that always pairs up with 1/2 is radical 3 over 2. And since this is going to the left, that's really negative radical 3 over 2. So since we need the angle, the reference angle, if you did that hand trick, if you like that, I need 3 fingers on the left. So I put down this finger. So that is my 30 degree. So that means that this reference angle is 30 degrees, or pi over 6. Now, the angle that we're actually looking for starts right here and goes to there. So it doesn't quite make it to pi. Well, since this is over 6, I'm going to change this pi to be 6 pi over 6. So what I'm going to have to do to get that angle measurement, I'm going to have to do 6 pi over 6 minus pi over 6, and that's going to give me 5 pi over 6. So theta, the angle I'm looking for in this problem, is 5 pi over 6. All right, let's try another one. So the next one here, we've got secant. And secant's one of those that gets a little bit confusing. So I'm going to change this to cosine, because the inverse of secant is cosine. And that means what I'm going to have to do here, find the reciprocal of this, I'm going to have to flip that over. So I put it over 1. So cosine would be negative 1 over radical 2. Now that's not one of those numbers that we're used to working with. So what I'm going to do, I'm going to multiply the numerator and denominator. I'm going to rationalize that. So now I have cosine theta is equal to negative radical 2 over 2. Remember, cosine stands for our x value. And since I want my x value to be negative radical 2 over 2, I'm going to have to figure out which reference angle matches up with that. So I'm going to graph. This one is telling us that I want to be between pi and 3 pi over 2. So here's pi, and here's 3 pi over 2. So that's going to put us in the third quadrant. So I'm going to make my triangle here. Make sure that it's touching the x-axis. I know my x value is negative radical 2 over 2. So what always matches up with radical 2 over 2 is another radical 2 over 2, and it's going to be negative since it's going down. So if you're going to write this as an ordered pair, it's negative radical 2 over 2, negative radical 2 over 2. So you need to try to remember which angles match up with that. That would be a 45-degree angle. The x and these are the same. The legs are the same. That's also pi over 4. So what I'm really looking for, that was just the reference angle. That's what I'm going to refer to find my real angle, is I'm going to go all the way around to here. Now, this is pi. That's always the easiest to work with. I'm going to change that to 4 pi over 4. And notice that this angle is going past that. It's bigger than it. So when I'm looking for theta this time, I'm going to do 4 pi over 4 plus pi over 4. And that's going to give me 5 pi over 4. So the angle I needed to find for this one is 5 pi over 4. All right, take a look at the next one here. Tangent. Tangent can be a little bit tricky because remember, tangent means sine over cosine or y over x. If tangent is negative radical 3, I'm going to need to get a pair of numbers that's going to simplify to give me negative radical 3. So I know that if I pair up my radical 3 over 2 with my 1/2, I just have to be careful which order, those 2's would cancel out. I want the top to be radical 3 over 2, and I want the bottom to be 1/2. Because look, when I simplify that, those 2's cross out, and I've got radical 3 over 1. I mean, it's not negative yet, but we'll make it negative. So that's what would simplify to give me this. So keep in mind, I need my y value to be radical 3 over 2, and I need my x value to be 1/2. Let's see where we need to graph this. I need to be between 3 pi over 2 and 2 pi. 3 pi over 2 is down here at the bottom, and 2 pi would be a full circle. So this time I'm graphing in quadrant 4. All right, so let's label this. The y value is radical 3 over 2. That's the side going down here. Since it's going down, that's going to make that negative. My x value is the one that's 1/2, and it's positive because it's going to the right. If I were to write this as an ordered pair, my x value is 1/2, my y value is negative radical 3 over 2. Now, if we go back and look here, notice when the y value was 1/2, 30 degrees is always across from 1/2. It always pairs up with that. Here, I've got radical 3 over 2. That angle is going to be 60 degrees, or pi over 3. And I'm going to go over this here again in a second. I think that would help. You can always go and get it back from your old notes. Everything's open note right now. All right, so I got my reference angle. My reference angle is pi over 3. But what I want for this problem to get my angle, I need to almost go around a full circle. So since this is over 3, I'm going to convert this. I want to change this so that it's a fraction. That would give me 6 pi over 3. 6 over 3 is 2. And since it's not quite going to make it that far, I'm going to subtract pi over 3. So the angle for this one, 6 minus 1, would give me 5 pi over 3. All right, let's review over our first quadrant. And then soon in the next video, I'm going to solve trig functions. So we were solving them here, but really I started you out. You were started out with, it was a little bit easier. We were telling you where to graph it. So it's going to be a little bit more involved. So if we look here, the first thing we're going to want to do is isolate the trig term. That just means get your sine, cosine, tangent by itself. Then we're going to find the reference angle. We just did that. We're going to do that again though. And then we're going to look for possible angles based on the sines. So let's start with the sines here. We know that in ordered pair, my x is going to be positive and my y will be positive in quadrant 1. In quadrant 2, my x goes to the left, so that's negative, and my y is positive. In quadrant 3, they're both negative because it goes left and down. In quadrant 4, my x would be positive and my y would be negative. Now, let's go over filling this into, and I know you've seen this a few different times. You can go back and rewatch some of those unit circle videos if you need to, but we really kind of just focus on the first quadrant. So this is the ordered pair, 1, 0. It goes over 1, up 0, and that would be a 0 degree angle, 0 radians. Up here we've got a 90 degree angle, or that would be pi over 2, and that would be the ordered pair. It goes over 0, up 1. Now, these are the ones, and Mrs. Campo showed you that handy circle, the handy trick. If you wanted to do that, this would be 30 degrees. That's the same as pi over 6. 45 degrees is the same as pi over 4. And 60 degrees is the same as pi over 3. Now, we need to get these ordered pairs. Everything's positive in this first quadrant. If I put down my 30 degree finger, I've got 3 on the left one on the right. So I have radical 3 over 2, 1/2. If I put down my 45-degree finger, I've got 2 on the left, 2 on the right. So I have radical 2 over 2, radical 2 over 2. And then finally, I've got 1/2 radical 3 over 2. So if I were to put down my 60-degree finger, I'd have 1 on the left, 3 on the right. So this I'm going to keep referring back to help us figure out our next set of notes, or our next set of problems.